Welcome back. We're going to cover more of the condition inspection now. Last time we were together, I took apart all of the interior panels, access areas, interior itself, the upholstery and stuff came out. Now the airplane is pretty much opened up and ready to begin the condition inspection itself. I'm going to be working off of a condition inspection checklist. I downloaded this off one of the Lancer discussion groups many years ago. It breaks up the condition into sections. So it's got a pre-inspection where you basically clean out the airplane, remove all your items, things you carry around with you that you don't need. And then it breaks the airplane up into groups called wing group, flap group, tail, landing gear, engine, which is the longest one. And then there's the cabin area. So that's undersea, make sure the flight controls, the joysticks are all good. Seatbelts are in good condition, things like that. Checking your flight instruments, which would be pitot-static system. In this case, since I have an all-glass airplane, there's not a lot to check, just a few items. And then finally you run up and then you button the airplane up and do a test flight. So for starters, I think I'll go through the cabin again in some detail, show you where components are, why things are laid out the way they are. And then after that, I'll start doing the inspection itself. Probably won't be able to show everything, right? There's a lot of stuff that's not that interesting to see or it's just too difficult to film. So we'll give you some of the highlights so you can get a feel for what's involved. So now that everything's opened up, we're going to take a look behind the instrument panel. The glare shield, the glare shield is held on by just 3 screws. Very easy to get off. So we'll start on the left side here. Taking a look around, it looks crowded at first, but it's actually pretty easy to reach everything. You can get your hand in here without too much problem to get to all the components you need to. Starting at the top, this is a manifold pressure sensor. This is feeds your manifold pressure into the Dynon engine monitoring system, which is this unit down here. This takes all the inputs from the engine. So the brown wires are EGT and CHT. So there's 12 of those. And then these wires here are the other things that you would monitor, such as oil pressure, oil temperature, fuel flow, also fuel level. The fuel level probes in this airplane were made by Electronics International, and they put out a pulse whose frequency is proportional to fuel level. However, the engine monitor expects a DC voltage between 0 and 5. So over here are 2 Princeton converters, which are frequency to voltage converters. There's one here, they're back to back. And those will put out a voltage, they're calibrated 0 to 5 volts. That feeds into the engine monitor, which then displays your fuel level. And there's a calibration process to set that stuff up. Back here, this cube right here is the backup battery for the Dynon EFIS. Anytime the airplane is running above 13 volts on the bus, this battery will charge, and it gives you about an hour of functionality time on the EFIS if you were to lose electrical power for some reason. This is the backside. This is a Dynon Skyview 10-inch HDX. This was a recent upgrade. That's the plug-in, which lets you display ADS-B weather on your tablet, and you can actually send flight plans back and forth. These are the backside of the landing gear lights and the fuel pump light. You can see here is the gear switch behind these wires. And let me take a look down. Rudder pedals, all standard here. I'm going to flip the camera a little bit so I can see. Let's try that. Nope, maybe not. All right. So coming down here, pardon me for the flip. On the motor mount here, you can see the canopy seal pump. So the forward part with the green base is the pump, and then next to that is a pressure switch. This lets you inflate the canopy seal and shut off automatically when it gets to a certain pressure, and then it holds that pressure. Turning over this way, we've got, you can see the red box is one of the 3. There's actually 2 of them, one stacked on top of the other using spacers. Below that is one of the main batteries. So there's a 22 amp hour, I think, 12 volt battery. Let's see if we can get an angle on that. So right here is your 12 volt battery. This is battery B. Battery A is back in the tail cone. Over here, obviously, this is the back of the GTN 750. And here is the GPS antenna for the certified IFR system. So this, again, it's under a fiberglass glare shield, and then it's under the plexiglass canopy, so reception is never an issue. It always picks up satellites, no problem. I'm going to come around to the other side. There's a little bit, not quite so much to see over here. As I say, there's two alternators, so I'm going to back out a little bit. These are BNC voltage regulators, 12 volt analog, so this controls the 70 amp alternator A and the 20 amp alternator B. It puts out the field current to regulate voltage. Over here, that's the backside of the Garmin G5. This is the Mountain High oxygen system. Over here, you can see a little bit buried. That's the ELT control, this guy right here. Here's your Hobbs meter. Wiring this relay board here is to control the illuminated switches in the cockpit, to give you some nice logic on how those work. You can see the heater tube, the big orange scat tube there, which lets warm air out by the co-pilot's feet, and there's always plenty of cabin heat. You can see that T-fitting right there. That is the brake lines going to the reservoir, so you're looking at the back side of the brake reservoir there. I'm going to hop up on the wing. And we can see, once again, looking underneath, you can see the outlet of the cabin heat is right there behind the right rotor pedal. These are just covers. Under this cover is the strobe light power supply. Like I mentioned, I have old school strobe lights. If there was ever a good reason, I could upgrade to LEDs, get rid of that unit, but it's kind of, it's been working fine since I first flew the plane. There's no reason to change it unless something goes wrong. This is the cabin, the parking brake. So this was a custom installation. It's kind of optional. You have to figure it out yourself. So you notice there it says parking brake on is forward. And there is a gotcha with this, which is this way is off all the way back, and you move it forward and then pump the brakes to lock it. And then to release it, you'd move it back, pump the brakes one more time, that'll release the parking brake. It can occasionally creep forward just slightly off the stop. So if you're taxiing, you notice a brake dragging, just slip out of your shoulder harness, reach over and make sure that's all the way back. Going over here, here's the control stick. Zoom out a little bit. So this is all standard Lancer. This is all stock system. This is a gear door cylinder. And then this is the sequence gear system here. So this is a four-way valve. It will reverse the flow to the inner gear doors at the appropriate time during the gear cycle. And this is the actuator motor for it. And it senses based on micro switches and just simple logic. Inside, you can see a little bit of the manifold. That's a passive component. It just joins up all the hydraulic lines. You can see some of it in there where all the lines come in one side. This here is the relay deck for the stick grips. So you notice I've got Tostin Manufacturing stick grips, and because this is the trim, so left, right aileron, forward and back is rudder elevator trim. And you can imagine if one pilot was going one way and the other pilot was going the other way at the same time, the relay deck handles all that stuff and cancels out any conflicting inputs. Come over to the other side. One important point here is when the seat pan is out, you want to step on the seat support here just to make sure you're not going to hit any components. Those can take away a person's weight. That's kind of a highlight of the cockpit area. Maybe I'll walk us through the instrument panel while I'm here. So, sorry about the external light. This is a 12-inch Dynon HDX display, touchscreen. So this does primary flight display, moving map, and engine monitor. And you can have any 1, 2, or 3 of those on the screen at the same time. This is a recent upgrade. I had a 10-inch Skyview Touch before that. But after something like 11 years of use, it was starting to get a little worn and faded, and the viewing angle was decreasing. So I took advantage of the trade-in, got a $1,000 rebate on this new guy. Over here are the master switches. So just like a Piper has a split rocker switch, in this case, there's a 2-position switch. So one click is battery only, second click is battery plus alternator. This is a cross tie, so you can connect buses A and B. And you notice it says right here's battery A, battery B. Ignition system, this is wired directly to the battery. So if you ever had smoke in the cockpit and you had to shut all the masters off, these can stay on. If I turn them on, you might be able to hear each one has its own cooling fan. Start a button. I wanted the button instead of a key. Just looks cleaner. I like it better that way. Here's my GTN 750. This is a blank panel here. I was going to put the transponder here, but I ended up with a remote transponder in the back. So the transponder is controlled off of the GTN 750. Here's my control switches. So boost pump, 2-position low high, landing light, taxi light, landing light. This is nav. 1 click is nav, and then 2 clicks is nav plus strobe. Pitot heat, you can guess from the logo. And then this last one is the autopilot. If any of you are fans of the movie Airplane, you might recognize our little friend here, Otto. Okay, coming to the right. There's my backup attitude indicator, not too far away. Oxygen control, intercom. This airplane has no audio panel because there's only one radio, so it would have been overkill to have all of those inputs and all those buttons on the audio panel. So try to keep it as simple as possible. Instrument floodlight. There's an LED strip under the glare shield. So you can, it kind of gives it a nice glow to this whole area so you can see things. These are defunct. These are from the original iteration of the instrument panel. I first flew the plane with Blue Mountain EFIS, and those needed a serial connector to do software updates. I put in some USB power. This used to be an Ethernet connector also. There's your hobs. Big circuit breaker, 40 amp for the hydraulic pump, and then just all the usual run of circuit breakers. Coming down to the center console, I've got the fuel selector valve. This is just standard Lancer. This is cabin heat here. So you just push the button and pull it out to set your cabin heat, and that regulates how much on or off you want. Standard mixture control knob, push-pull plus vernier. And this is the flap switch, momentary down, and it latches in the up position so you can retract all at once after landing. Over here's the throttle. This is where I differ a little from the standard system. So I've got a lever type throttle. It's very comfortable. You rest your arm here and you've got easy control, fingertip control of the throttle. Same goes for the propeller control. You can pull that back, all the way back feathered. You can get the prop all the way down to 800 RPM. So when you're practicing engine out, you can extend your glide by putting the prop to course pitch. Go forward to stop 2700, full throttle here, obviously, and then back to idle. And mixture cut off. Here's the glove box, and I actually marked up, I stenciled on here using a silkscreen company. I put it on the control so you know what all the stick switches do. I think most of the highlights for the interior. So we'll continue on and figure out what we're going to talk about next. So we're going to put the jacks in place. In certain cases where you want the landing gear to be up rather than down. I'm going to need them later for gear swing anyway. I might as well put them in. So this thing goes under the main spar, which is just about at the front of the wheel well, right about here. So get it as close as we can to the tire and as far back as we can. And then we're going to put the jack pad on there. The jack pad is just 2 pieces of 3/4 plywood. There's a hole here, and then just some rubber padding material on the top. And then I use a soft cloth just so I don't scratch the paint. An important point here is you want to make sure you're not going to come in contact with the gear door. I've actually gouged these a little bit when jacking up the plane when I wasn't careful, so I got to make sure that they're far enough away. And the reason I'm jacking up the plane right now is because I'm working on the ailerons. So sometimes it's easier with the gear retracted to reach the linkages and the bell crank and so on. So I'm going to grab a piece of strap and put the gear up and see if the access is a little better. So there's a couple of quick releases here. And then a couple of plungers in the top pit, which of course are a bit stiff. And there's the gear door. Where's the camera? The gear door's over here. You just move these plungers like this to get them off. And put this out of the way so I don't scratch it. So the next step is going to be to raise the landing gear and temporarily hold it up using a strap. This is for towing motorcycles on trailers. This thing loops around the handlebar, and then I'm going to secure it just with a piece of plastic pipe. This strap will go over the landing gear reinforcement bracket. Adjust it about here so I can see both ends. The dump valve has to be open for this because the fluid has to be able to flow freely. So the trick is to break the over center link with your foot, and then you can raise it by hand. Get the straps, one on each side. Hold the gear up and loop this guy through. Now I can see much better up in here, but there's a whole bunch of systems I got to examine, so we'll get some film of that. So just to give everybody an idea, with the wheel retracted up into the wheel well, I actually have a much better view. Let me try and get this to focus up here. Much better view of the linkages that are here. So I'll be able to get my LPS spray nozzle on there to lubricate those. I can inspect them, check for play, and so on. Also, it's going to give you a chance to inspect the fuel line. Remember I had mentioned concern about chafing with the brake line, the hydraulic line. So I can get in there with a mirror now and inspect everything. So that's kind of the idea of why it's actually easier to work on certain things with the landing gear retracted. So I'm going to take this camera, pull out my flashlight, and we'll see what we can see. So back here, there's not a whole lot. There's a couple of hydraulic lines. This is the aft part of the wing spar. The braided one is the brake line, and just a few connections going through to the underseat area of the cockpit. Coming around to the front. So there's my linkage. So you can see that there. Limited by the flashlight. 1, 2, 3 points have to be lubricated. Check nuts appear to be tight. We'll give them a manual test in a second. And then once again, here is, so we can get a light on there. Fuel line is this red guy right here. And we check, we can see that the brake line, let's see if I can get that hand on that. This brake line here is not touching, they're not near each other. So that's a good sign. This thing is doing what it's supposed to do. It's got a service loop in it because the gear moves, and that's it. So now I'm just gonna get in here and spray this with some LPS2. One part of lubricating is doing all of the flight controls along with hinges. I mentioned the aileron control is a piano hinge, so I put tape on either side of the hinge. I'm gonna raise it up so it kind of forms a V here. I'm gonna take my LPS and use that to fill in the valley. You don't need the tape, but it just kind of make an oily mess that you have to clean up eventually. So I got enough left here. Be pretty generous. It's gonna drip down into the cavity, but that's okay. I'll clean it up a little degreaser when I'm done. And this is penetrating oil, so it should seep into the hinge, get down between the aluminum hinge loops, and kind of lubricate the metal pin inside, prevent corrosion, and also hopefully prevent it from beating up the hinge loops too much, because the steel pin is obviously much tougher than the aluminum hinge loops.